So if you're watching this, I'm going to guess that you are curious about hurricanes. Luckily for you, the next few minutes will cover the basics of everything there is to know about the mechanics and destruction of hurricanes. And without further ado, it's time for everything you could possibly want to know about hurricanes. If you think of a hurricane and you think of the Atlantic Ocean, warm water, and a storm, you're on the right track. If not, no worries, this video has you covered. So hurricanes are a type of tropical cyclone that occur only in the Atlantic Ocean and the Eastern Pacific Ocean. They commonly occur during the months of June to October when the ocean water is warm enough to get these storms a-brewin'. Thankfully for us humans who love our beachfront real estate, not all storms become hurricanes. A few conditions must be present for a hurricane to successfully form. First, the ocean waters must be at least 26 degrees Celsius. Without that minimal temperature, there is no way a hurricane would form. Second, a hurricane originates as a small, low-pressure disturbance, but that pressure has to continue to drop. From here on out, the hurricane gets a little demanding, a little nitpicky, if you will. You know all those high winds caused by hurricanes? Yeah. Well, those winds can only occur in the presence of the following conditions. A hurricane only forms if the area just above the disturbance has a relatively high pressure so that those strong winds can get their gust on. You think that's bad? Well, those strong winds only happen if the original disturbance forms within a very specific kind of air current. The air current must be broad with a very weak vertical wind shear. I told you that these hurricanes were demanding. So the last thing you're probably wondering about is how these storms spin, right? Again, very specific conditions must be present for rotation to occur. For rotation to start, the air flowing towards the disturbance must be deflected away from it. If this air is deflected, a spiral structure forms naturally and rotation begins. So how does this air get deflected? By a wonderful little phenomenon known as the Coriolis effect. This is a phenomenon which impacts masses of moving air. So in the northern hemisphere, the Coriolis effect causes air moving towards a hurricane to deflect perpendicular and right to the direction of the air's motion, just like this. So basically, the quick and dirty is that you have to have ocean waters above 26 degrees Celsius, dropping pressure in the disturbance, weak vertical wind shear, and the presence of the Coriolis effect. Now that we've established what it takes for these hurricanes to form, it's time to talk about the classification and destruction of these storms. But first, I've got to share a little disclaimer. While some hurricanes are more severe than others, the key point is that all hurricanes are dangerous. If a hurricane is predicted to impact where you live, you should do a little less preparing for those oh-so-popular hurricane parties and a little more stocking up your family with enough food, water, and medicine to last for up to a week. Whew, but I digress. I was trying to tell you about the Saffir-Simpson scale. This scale measures the severity of impact of a hurricane based on the storm's central pressure, average wind speed, and ocean surge levels. Each category is also associated with a level of predicted damage. So first up, we have a Category 1 storm, categorized by a central pressure that exceeds 980 millibars, with wind speeds between 33 to 42 meters per second, and ocean surge levels between 1.2 to 1.6 meters. Predicted damage for these storms is minimal, with most damage caused to landscaping, piers, and by the flooding of coastal roads. A recent example is Hurricane Dolly, which impacted South Padre Island, Texas in 2008. Then we have Category 2 storms with lower pressures between 965 to 979 millibars, wind speeds from 43 to 49 meters per second, and surge of 1.7 to 2.5 meters. These storms are likely to cause moderate damage, generally impacting exteriors of homes and causing some coastal flooding. Hurricane Francis was a Category 2 storm when it hit Florida in 2004. A Category 3 storm has central pressures between 945 to 964 millibars, winds between 50 to 58 meters per second, and ocean surge levels between 2.6 to 3.8 meters. With this category of storm, an area is likely to experience extensive damage, with the chance of small coastal buildings and mobile homes being completely destroyed. Gulf Shores, Alabama experienced this category of storm when Hurricane Ivan struck in 2004. Next in the classification is Category 4, with central pressures between 920 to 944 millibars, winds between 59 to 69 meters per second, and surge levels of 3.9 to 5.5 meters. Damage from these storms is extreme and often results in severe beach erosion and the need to evacuate residential areas inland up to 6 miles. Infamous Hurricane Andrew of 1992 is an example of this category of hurricane. The most severe hurricane is a Category 5. These storms have pressures below 920 millibars, winds that exceed 69 meters per second, and surge that is over 5.5 meters. Every source I've found describes these storms as causing catastrophic damage. It is rare for these storms to reach landfall at this intensity because the environmental conditions we discussed before are very hard to maintain. In 2007, however, Hurricane Felix was a Category 5 when it made landfall in Nicaragua. And there you have it, folks, how hurricanes form, how they are classified, and the destruction they cause. See, I told you it would be everything you could possibly want to know about hurricanes.